me 1 minute.
Yeah. The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Windows 8 background tasks and push notifications. And our guest speaker today is Samiksha Khare. She's a technology evangelist, DPE, Microsoft India. Samiksha works as a technology evangelist with Microsoft India, and her core technologies are Windows 8 and Windows Phone 8 app development. In her current role, she helps developers with Windows 8 app development. So, without further delay, I introduce you all to our guest speaker. Over to you, Samiksha.
Thank you so much, Radha. Hello, everyone, and welcome to the fourth and the last session in the series of the 4 session on Windows 8. My name is Samiksha Khare, and I am a technical evangelist with Microsoft. And as Radha mentioned, I work with partners to develop Windows 8 and Windows Phone 8 applications. So let's get started. The agenda for today's webinar is first the overview of the multitasking model. So basically, if we have to understand what is background task and why do we have background task, why do we need to use background task, we have to take an overview of the multitasking model. Next will be background task architecture, I will talk in brief about what the key architecture of background task is and how it will give us a little bit of clarity in understanding. Implementing a background task, I will show you 3 slides which has some code in it. You don't have to write down the code, but you can understand it better. Connected standby and background tasks. Connected standby is a very interesting concept. We will take a look at connected standby and how it is related to the background task, or how does background tasks relate to or react to connected standby mode. What's new in Windows 8.1? We have certain, not many, but few changes in Windows 8.1. So we will take a look at those changes. Best practices, do's and don'ts. This slide will talk about what is it that few things that we have to keep in mind while developing background tasks, and what are few don'ts that we should totally avoid. Notification hub, push notification lifecycle. We will talk about what is push notification, what is notification hub, what is the advantage of notification hub, why do we use notification hub, which we'll cover in the part of challenges in push notification. Finally, sending notification to specific devices and delivery guarantee and telemetry. This is today's agenda. Let's keep a protocol over here that if you have any questions in between the webinar, you can ask all the questions after this session. We will have 10 to 15 minutes of time for question and answer round. So keep noting down your questions and we will take questions after the webinar. So multitasking model. When Windows 8 was designed, it was designed keeping in mind the consistent battery life. We wanted to have a proper battery usage model which did not kill system if you have tens and thousands of applications running together, or if you had one application running. So to provide a great user experience and to ensure consistent battery life, Windows 8 app lifecycle was designed. When we talk about Windows 8 app lifecycle, there are 2 concepts called suspend and resume, which are of very high importance. So if you open one application in the screen, and after that if you open few more applications, the previous application goes into the suspend mode, which means that the previous applications whose pixels are no more in the screen does not use any CPU resources or any CPU cycle. So in this case, all the resources, CPU resources, the system resources are given to the applications which are running on the foreground. So apart from that, but users have certain scenarios which requires the app to run when they are in the suspended mode, or when they are in the background, or when they're not in the foreground. So such scenarios which require apps to run in the real time, or such applications which is required to run and provide the real-time content, can do so in many ways. Like live tiles, which is nothing but pushing off a notifications into the tiles and updating the tiles so that user can look into that. Scheduled hosts and notifications, also when the application is in the suspended mode, notifications can be given in the form of toast or batch, background transfer and background tasks. So here is where background tasks come into picture. When we want to execute certain code in the application which is not on the screen or which is suspended, we can do using background tasks. So as a part of introduction of background task, what I would like to bring your attention to is that background task allows application to run the code in the background. That means there is a certain characteristics related to it. It has to be a very short running task which performs some certain activity or which runs and give you some kind of output and then go away. We cannot have a very long running task, or we cannot have the services to be completely running and then giving you certain output in the background task mode. Third will be run regardless of the state of the app, which means that if your application terminates, if you have scheduled your background tasks such that it should run in every interval irrespective of the state of the application, it should do so, and it should perform under the strict resource usage quota. Since these application runs in the background and we want Windows 8 to use the system resources properly so that we can conserve, so that we can use the battery properly and not overuse it, or so that it gives a bad user experience, we have decided that we'll give a particular resource quota for each background tasks which run. If the application overdo the resource quota, we send them a cancellation and they have to cancel the background and terminate. If they're at par with their resource quota, then it's fine. They can run properly. So these background code, there's nothing very different in these background tasks. They can run as a simple. They can run as your application would run. They can execute the same task as your application is executing. Just that they should be short running tasks and they should not overuse the resources. They should be under their. They should be at par with the resource quota. So what can you do in a background task? Like I mentioned, this background task runs in the same app container as your own app. So it's your own app code. It's nothing new. You can do whatever you're doing in the background task which you're doing in your application. So let's say your application is a news application and you are trying to fetch some data. You are trying to fetch some data from the RSS feed from some newspaper to your application, and this is the core functionality of your application. You can keep doing this in a background task, but the point here is don't make it a prolonged activity. If it's important, you can make it periodic, like every 1 hour or every twice a day or something like this. So whatever functionality your application has, the same functionality can be done in the background tasks. Most APIs are accessible as it is. Audio and video are not accessible due to privacy concerns. So we do not allow audio and video sorry, we do not allow audio and video to be accessible in the background tasks, because what may happen is if you're having a conversation, these background tasks may come up and then snoop in your conversation, which is strictly not desirable. So audio and video are not accessible. No other UI other than toast, batch and live, and tile updates are there. So through your background tasks, you cannot bring the background, you cannot get the application into the foreground. There's no Win32 or there's no bring the application in the foreground sort of method available. You cannot bring the background application in the foreground. If you want to communicate, you can do so by using toast batch or toast notification, badge notification, or the tile notification. For those of you who do not know what toast notification or the badge notification is, toast notification is nothing but the notification which comes on your laptops or tablets on the top right corner in a rectangle. So whatever information comes in the top right corner in the rectangle is called as the toast notification. And if you have seen the tiles for any application in the start screen of Windows 8, those tiles have a small number in the bottom right or a bottom left corner. Those kind of notifications are called badge updates. So you can use background tasks to update badges, to update the tiles through flipping of the tiles or making the tiles as live tiles or giving the toast notification. Well, this is why we use the background task basically. So use background tasks as you would use your normal application, and then update these notifications so that users can be aware. User can be made aware for the relevant information. Now, how does background tasks work? They work by using triggers. So basically, what happens is, if you have, okay, let's take a look at the first background task trigger, which is control channel trigger. Control channel trigger are used in VoIP apps. VoIP apps basically requires you to have a socket available with the proper connectivity to the server for a long time. If the application is suspended, we still want the connection between the socket and the server to continue the VoIP application. So what happens is there's a trigger available, which is the control channel trigger. When the packet arrives in the socket, this trigger is notified that there's a packet which is arriving at the socket. Then the trigger is notified, and when the trigger is fired, the system fires the trigger and execute the background task. This is the core working of the background task. So control channel triggers are used in the incoming VoIP applications. Device use triggers, device servicing triggers are the two triggers which are available in Windows 8.1. These are used for USB and Bluetooth device sync. Also, they're used to update the firmware. Next is the location trigger, which is also a Windows 8.1 trigger. It is used to create a geofence around a GPS location. So, if you have marked a place and created a fence around that place and your device enters that geofence, this trigger is fired and the corresponding background task is executed. Maintenance trigger performs maintenance work on the AC power. Maintenance triggers works only on the AC power. And it's available for all kind of applications. Push notification trigger, incoming WNS, which is Windows Notification Service push notification to initiate IM conversations. So if you have any kind of push notification services happening, push notification trigger is used so that the corresponding background task can be executed in the background. System trigger run code when the user on the internet is present. System triggers are basically a bag full of triggers available for the developers. Probably there are certain scenarios that we have identified which may be useful for the developers, and there are triggers, or the system triggers are provided for them. So let's say that for a particular scenario or for a particular application, there are few conditions that you have to, few conditions that needs to be satisfied to execute the background task. So if you have a few conditions such as, let's say there's a scenario where you need to have the user who's away from the, let's say there's a messaging application and you need to update the status of the user who's away from the, who's not in the messaging application and who's away from his laptop or tablet. So there are two conditions here. First, the internet should be available. Second, if the user is away. So these kind of scenarios are there, and triggers for these scenarios are provided under system trigger, which developers can use in their application. Finally, the time trigger. Periodically download POP3 email every 15 minutes. So time triggers are basically used for the applications which run a certain amount of code periodically. 15 minutes is the minimum of the time limit which is provided. That means that you cannot have a periodic update or the time trigger for less than 15 minutes. These are some triggers which are available in Windows 8 and 8.1. Now let me take your attention to the lock screen required, which is the last column of this table. For some of the triggers it says yes, and for some of the table it says no. Next slide is dedicated to lock screen, so I'm going to cover it in the next slide. But the system triggers, if you look at the lock screen required entry for system trigger, it says no with a star. So basically system triggers has many triggers under it, and some of those require the lock screens and some of those do not. There are certain triggers which may require the lock screen and which may not. Hence, we have put a no with a star for system triggers. Just for other triggers, it's confirmed whether they require the lock screen or not. Lock screen and resource model. Generally, people ask what's with the lock screen? Why do we need lock screen? I want to make my application, I want to run my application in the background, I want to give some result and then come back. Why do I need lock screen? So I'm going to try to answer this question here. So basically there are two reasons why lock screens are required. So the first is that, let's say there's a user who's using a mail application, and mail application syncs up and update the mail in the background. So there can be a user who receives 1 or 2 mails every day, and there can be a user who is using hundreds and 200s, who's receiving hundreds and 200s of emails every day. So the point here is resource usage for an application which is running the email background task is not in the control, is totally in the control of user, and is not predictable. There may be days in which there is a spike of the emails that a user is receiving, and there can be days in which there are not much emails which are coming up. So the thing is, the battery, let's say, and like this, there are hundreds of applications which are using the background tasks. So what happens is, to predict or to forcefully give control to the user as to how many applications can run background task at one point of time, lock screens applications are given. So that at max, so that user knows which application is running in the background. So that user knows that if something goes wrong, he knows which are the applications which are running in the background, and he can terminate them or change them or use them according to how he wants it. But at least user should know where he can find the tasks or where he can find the applications which run in the background. Of course, there's task manager available for this, but not all users are aware of that. So this is the first reason. Now another reason is, if you have the applications on the lock screens and which execute the background task, we can have a upper bound to the resources, that max resources, or upper bound to the max number of background tasks that can run at one particular time. So if there are 6 or to 7 lock screens available, we know that at max only 7 applications can run their background task. So this is another reason. This is another reason we have lock screen application, to put an upper bound on the background tasks. Time to look at the architecture of the background task now. So what happens is, basically, how you need a app builder class. You need a builder class to run the background application. And you need to have you need to register your background tasks. You need to have a trigger. You need to have a class name. You need to have entry point, conditions, and triggers. So basically, we have a background tasks run as our DLL. Our DLL takes all this information and register this information with the background task infrastructure, which is the lowest in the architecture, the gray tab. This background task infrastructure maintains a database with the app name, their entry point, and the trigger. So what happens is, if let's say, and these triggers are basically a part of the services which are mentioned in between. There are system event services, time trigger services, Windows push notification service, control channel service, location service, device service. All these services basically execute what the trigger wants to execute. So what happens, for example, the control channel service contains, here's the socket, and as soon as the package, let's say there's a VoIP application and there's a socket which is connected to a server, and the packet approaches the socket. I'm taking the old example again for more clarity. What happens is, if there's a packet coming to the socket, the control channel service listens to it and then alarms the trigger or fires the trigger. The background task infrastructure, when it knows, okay, this is the trigger, it maps in the database that which class needs to be activated corresponding to this own trigger. And this is how it then executes the class and the background task is executed. So this is a very, very high level diagram. This is a very, very high level explanation of the background task architecture. But there are other components here. But I think it's okay if we don't go into we don't go there, because whatever I have explained is enough for developers. So this is the basically background task architecture, where background task infrastructure maintains or maintains a database with the trigger name, the class name, and the app name. And then triggers, the system services are there for executing the background task infrastructure maps the trigger with the class, and the class executes the background task. I hope this is making sense. Moving forward, we will take a look at writing the background tasks. So basic fundamental about writing the background task is that you can write the background task in any of the Windows runtime language, C#, C++, JavaScript, VB, any of these languages. In fact, it's highly recommended that you decouple the background task with your applications, which means that if your application is written in other language and your background task is written in other language, it's not dependent on each other. For example, the mail application which is there in Windows, the mail application is written in JavaScript, but the background task for the mail application is written in C++. So the point here is you can author the background task in any of the Windows runtime languages. It should be manifested, which means that in your app manifest file in your Visual Studio, it should be mentioned. If you are implementing a background task, it should be mentioned there in the declaration tab. Also, it should be mentioned which trigger you're using, what is the entry point. If you do that, what happens is when you submit your application for store certification, the team knows that okay, this is the application which is implementing the background task. They will test this application a little differently, and they will be aware that okay, this application is using this trigger, and they can do the proper testing for that application. App must run to register background task. They can have one trigger or 0 or more conditions. So apps can have exactly one trigger that we've seen, the triggers we have seen, and 0 or more conditions. These conditions are nothing but the conditions you require for execution, like user should be away or internet should be available, etc. If you have more than 0 or more than one conditions, all these conditions needs to be fulfilled for background tasks to execute. Finally, all background task registrations are persistent, which means that all background task registrations are persistent. This means that, here's an example for that. If there's an application which is required to execute a background task after one hour, and at 20-minute timestamp the system reboots, and then at 21 timestamp the system reboots and the application is not launched or suspended at this point of time. When the time reaches 60, since the background task was already registered with the background task infrastructure, the background task will execute. This is the power of persistent application, persistent storage, that you don't have to register the task again. You don't have to register background task again with the background task infrastructure. And even if the system, even if the application is not launched or is not suspended, the background task will execute. There's another side to it, which is that if next time your application is launched and you are trying to register the background task again, it's a good idea to check if the application is previously registered or not. If it is previously registered with the background task infrastructure, you can delete it and then re-register it. So this is about background tasks and the languages you can use and the declaration that you have to do in the manifest, and how you can have only exactly one trigger, 0 or more conditions, and how the background task registrations are persistent. Let's look at this slide which has some code on it. If you can see the first line in the method, which is background task builder. So this class is a builder object which asks for the name, the class name, the trigger, and the entry point, and the conditions. Also, there is task.progress and task.completed handler. So in case you want to show the progress of the background task which is happening, you can do so by using task.progress handler. And if you want to notify the user after the background task is completed, you can do so by using the task completed handler. So this is how you register for a background task. Next, this slide talks about how background tasks run our implementations. So, well, all of these sample codes are available on the MSDN, so there's nothing to worry about that. But there is just one thing I would like to get your attention on, which is task instance.cancelled or new background task cancelled event handler. If your background task does not have the cancelled event handler, it's not a good idea not to have it. It's always better if you have a cancelled event handler, because what happens is sometimes if your application which is running in the background is overshooting its resource quota. I've mentioned before that each background task has its own resource quota available. So if a background task is overshooting its resource quota, or there are some situation which requires the system to cancel the background task which is running, your application should be able to handle this cancel. If you don't do that, the application gets terminated by itself, which is not a very good scenario. So always remember to implement the cancel event handler in your background task run implementation. This is this slide. This slide shows you the app manifest, where you can see that a background task is added in the supported declaration, and entry point is marked, and the system triggered or the task type is marked. This is just to show you that this is how the app. This is what you will have to do with the. This is what you have to do in the manifest. You can choose background tasks from the available declaration, pick up the supported task type, and mention the entry point. Now, there are a lot of developers who says that I'm doing everything right, I've got everything, I've written the code correctly. Still, I'm facing some problem and the background task is just not working. For that, we are providing debugging background task methods. There's a background task event viewer which can give you all the information about your background task, like what are the resources it is using and when it is starting, when it is terminating. Lot of information, all the information that you want is available in the background task event viewer. So you can go take a look at that. Along with that, in 8.1, there are PowerShell commandlets which are provided. You can run these commandlets and get all the information you want for your background task. So these are the two methods we've given for debugging of the background task. Go ahead and try these when you are playing with background tasks at home tonight, if it gets you excited enough. So debugging is not a problem now. If you have any confusion regarding debugging, you can either use background task event viewer, or you can use the PowerShell commandlets. This slide, next slide, this slide talks about the common gotchas. You can read it by yourself. It is available in the MSDN, but I would like to mention point number 3, which is forgetting to call the close in JavaScript. If there is no close in your background task will keep on running. And like I told you, not using the battery power unnecessarily is the whole reason why background tasks are there, suspend and resume are there. So it's always good to put a close at the end of your background task in JavaScript. This, by the way, is a WAC test failure in 8.1. So make sure when you're writing your background task, you do not forget to mention the close at the end. Apart from that, all the other common gotchas which I mentioned, like output type of the class library is not Windows runtime component. Yes, this is another one. You have to write the output type of the class library. If it's not Windows runtime component, then you will not get the desired result. Background task entry point is not accurately described in the manifest. Make sure you do describe the background task entry point properly. App not on the lock screen and hence background task is not triggered. Not using Visual Studio to trigger and test your background tasks. So these are some common gotchas which people make. So try to avoid these in order to get the desirable result. Moving on, connected standby. Connected standby is another state which means low on power and low on network, which means that CPU at this point is the lowest on the power. So only way to run code in the connected standby mode is through background tasks, because everything else is not allowed to run since the CPU power is low on power. When you're trying to run code in this connected standby mode, the system is taken out of the low power mode. If your code requires some network connectivity, the network is taken out of low power mode, and then you can run your application. So you can basically get the real-time emails or VoIP calls in this connected standby mode. If you want to understand what background tasks are running and how much are they, what is the list, what are the active background tasks at the connected standby mode, there's a utility in System32 which is powerconfig.exe/sleep study. You can go there and you can check out the list of active background tasks in the connected standby mode. Here is HTML, which is what you will see when you put this command powerconfig.exe/sleep study, and you can see the task entry point and you can see the active time and everything. So all these details are available for you to see and understand what is the active list of background tasks in the connected standby mode. Power comes with responsibility. So since there's a lot of here we'll talk about, we've seen few things from our telemetry, which is these lessons are collected over on the user machines. We've seen that developers forget to use internet available condition. So network is lazy, causing long wait periods. So what happens is, let's say your background tasks requires you to fetch some data and requires you to have internet connection available. In the connected standby mode, since your background task is going to run, the system will be taken out of the low power mode. But since you forgot to use internet available condition, the network will not be taken out of the low power mode. So low network mode. So what happens is the background task or the code will keep on waiting because there's no internet connection available, and system is already out of the low power mode, so a lot of battery consumption is happening with no proper result. So hence a system, we have something called idle task detection, which happens. So if the background task is ideally waiting with no proper output because developers forgot to use internet available or some other condition, we try to cancel them, and your app catches the cancel event handler and then properly unwind from your background task. However, there's another gotcha here, that the developer forget to add a cancellation handler. Remember, I told you that this is a common gotcha, that put close and put a cancellation handler. So if developers forget to add the cancellation handler, then the app will unwind without, it might unwind improperly, it might corrupt some data. So two things. First, don't forget to give the proper conditions to run for your background task. Second, always mention the cancellation handler. Never forget to put the cancellation handler, because there may be scenarios which requires the user to which requires us to cancel your background task, and your app should be ready for that. Resource constant. All background tasks have CPU and network usage quotas. Quotas are based on actual usage instead of wall clock time limits. Although wall clock time is very familiar and very familiar unit of time that we use, but the resource quota which is given to the background task is done on actual usage, actual CPU usage. For example, if your application is running on the background and which wants to get some data from internet, let's say it's downloading some data from bing.com, most of the time it will be waiting for a response from the bing.com. So it's not fair to charge your application when it's doing nothing but just waiting. So the more fairer usage or the more fairer calculation can be done on the actual usage of CPU. So that's why quotas or the resource quotas are based on the actual usage instead of the wall clock time limits. There's another concept called shared global pool where apps can request resources. Let's say you're having a VoIP call happening and you run out of your resource quota. We can't terminate the VoIP call now, can we? Because it's a bad user experience if we do so. So what we can do, what can be done is the app requests resources from a shared global pool of resources which is available, and so what happens is user can give the system can give these resources and the app can run in continuation. This all happens in very transparently. Developers are not even aware, the app's not even aware. The shared global pool resources from shared global pool is given. This is another concept called critical background task, which is basically the VoIP sloshing call capable background task, a critical background task, which receives the guaranteed resource quota of 2 CPU cycles. So these are important or a very critical background tasks, and hence we give them guaranteed resources. These are the resource quota value. I'm not going to read the values because these are well documented in the MSDN. But however, I would want to take your attention on the left hand side, which says use PowerShell to use the resource usage of your background task. And second, test with global pool disabled. So before you submit your application for storage, store certification, it's a good idea to use the PowerShell command to see exactly how much resource is your application or the background task consuming, whether it is appropriate or not, how much, if you can reduce it in some way, you can increase in some way, and always test with the global pool disabled. So what will happen is, let's say your application runs out of your quota and you're counting on the global pool resource, but at that time global pool is giving its resource to some other application. So your application will come into the, so you won't be able to receive the resource, will you? So test your application with the global pool resource disabled, and try to check with PowerShell what is the resource, how much is the resource usage for your background task. Moving on, what's new in Windows 8.1? Nothing much, basically. Quiet hours is something we'll talk about in few minutes. More background task triggers, like I mentioned. Cancel on condition loss. This also we have seen, and more developer tools such as PowerShell commandlets. Quiet hours. Quiet hours are basically nothing but out-of-the-box time which is fixed by the system, which is 12 a.m. to 6 a.m., where no background task activities is allowed to run. No notification, nothing. But two applications can still run, which is lock screen call capable apps and the alarm toast, which are raised during the quiet hours. These two can run as it is. What happens is, during this time, whichever application is entering into their background task, they are cancelled, and which they're cancelled on the entry and they're queued. So as soon as the system comes out of the quiet hour, there's this whole queue of background tasks, and then they can execute. However, if you are active on your system during the quiet hours, at that time everything works as it is. Then we do not terminate the background task. Everything can sync up, and the RSS can be fed, emails can be synced up as it is. So this is the concept of the quiet hours. Other background task updates, new trigger, we have seen location trigger, device use triggers, which is for USB and the Bluetooth device sync. Background work cost change. This is another new trigger in 8.1, which means that this trigger basically tells you that whether you can do more activity or less activity according to what is the condition of the system at that point. So if the background work cost change is low, if the background work cost is low, that means you can do more activity in the background task, and if it is high, that means you need to lessen it. Then cancel background task on condition changing. Cancel on condition loss. What happens is, let's say you have a condition, remember I told you that for background task there can be 0 or 1 condition, and you need to satisfy all the conditions for the task to run. So cancel on condition loss means, let's say you have a conditions internet available, but you go into a tunnel and there's no more internet available over there. So what happens is, you don't have to do anything, you don't have to save the state, or you don't have to unwind. We will try to understand if you have implemented cancel or condition loss or not, and if you have, corresponding the background task will be cancelled and properly unwound. So these are the few other updates. Do's and don'ts in Windows. Do's and don'ts. Well, again, I'm not going to go through the whole list, but a few points. Decouple the background task from the main app. This we have seen. Use persistent storage to share data between the background task and the app. Register for the background task cancellation handle in the background task class. So these are few do's and don'ts over here. Let's move forward and try to take a look at notification hubs. Notification hub, these concepts are very simple. Notification hubs makes it easy to push multi-platform personalized notification both to single users and very large group. How it does it? Let's try to take a look at that. Why notification hub? Push notifications are very, very essential to user experience for many applications, because it's really invitation back for the user to come to the application and engage with the content once again. So it uses user engagement, if you're updating the tiles, if with the new weather information or a financial information, it's an invitation back to the user that come and have a look at the new content. Similarly, if there are new badge information available on the tiles, or with some important notification like current sales lead in CRM application, user is tempted to go into that application back. So basically, that's why a push is essential, so that it increases the user experience, and it also increases the user engagement. However, the real world apps have a little complex needs. Let's say there are multiple platform pushes. There are different platforms available, not just one. So each platform will have a different requirement, and we have to push the notifications on these platforms according to how is one platform. Second is localization. Some apps may require the local language, the notification to be pushed in their local language. So we have to take care of it. Some user preferences. Some users may want the weather update in degrees Celsius. Some may want it in Fahrenheit. So we have to make sure that we take in account of user preference when we are pushing notifications. Different client app versions. So each app has different version. So we have to make sure that which app version is running where, because some notification may not run on some versions and some may not run in other versions. And finally, scales. On the right hand bottom side, you can see a screenshot of a tile, which is a news app, which is using notification hub to notify the users, or to push the breaking news, or to push the headline of the news to all the people who are using these applications. Now let's see a little bit about push notification. Push notification requires a platform-specific services. Each platform, whether it's Windows, iOS, Android, have their own different push notification service, and each of them are of different capabilities and protocol. Like Windows Store requires WNS, Windows Phone requires WPNS, iOS requires APNS, and Android requires GCM. These are the notification services that these platform requires. An end-to-end solution may require a lot of back-end code, because you have to keep and maintain the device information so that you can send the push notifications to them. You have to also take care of the platform specific protocols. All of this makes end-to-end services, end-to-end solutions, lot of back-end, like, heavy effort. So let's see the push notification cycle. Mm, on the registration or at the app launch, the client app, which in the diagram you can see is a phone, contacts the platform notification service to retrieve a current channel or a current handle. In Windows, it's called as a channel URI. So the client app contacts the PNS, which is platform notification service, and retrieves a handle, and then update the backend with this handle. Next, what happens is, when there's time to send notification, the app backend send notification to the PNS, which is the platform notification service, and then PNS pushes the notification to the app on the device. This is a simple push notification lifecycle. It's really simple. Client gets to PNS and asks for a handle, which is channel URI in case of Windows. Then client app updates the app backend. App backend sends notification to PNS, and PNS pushes the notification to the app. Just this, like, couple of steps, and this is all. There can be scenarios where PNS rejects the handles which the app backend is sending to it, and so there's a maintenance for that. You have to delete the expired handles when the PNS rejects them. Challenges of the push notification. There are a couple of challenges which push notification faces. First is the platform dependency, which I have talked to you about, because there are different communication protocols to each of the platform notification service, whether the communication should be HTTP or TCP, whether it should be HTML payload or JSON payload. Along, not just the communication protocol, there's a difference in the presentation formats and capabilities as well. Whether you want to do a tile notification or a toast versus batch, all of this makes platform dependency as a challenge that the push notification face. Along with that, the next is routing. Platform notification service, sometimes what happens is we have to maintain, there can be scenarios where we have to maintain an interest group, or we have to gather certain users and make them in one group and then give notifications to that particular group. So the app backend has to maintain a registry sort which has the associating device handles and the interest in the group users. All of this makes the backend works a little more. So this is another challenge that push notification face. Along with that, there's scale. As an app backend has to store the current handles for each device, and if if there are lots of devices, then it's a high storage and the VM costs involved. So the scaling becomes another challenge for the push notification. Now, how do we, if we have so many challenges, how do we handle them? Is there any way to deal with it? Well, there is. It's called, we can use Notification Hub. What happens is you have to do a one-time setup. You have to create a Notification Hub in the service bus, which is Azure Service Bus. Then what you do after the creation of the Notification Hub, you register. The client app retrieves its current handler from the PNS. This step remains same as in the push notification lifecycle that we've seen earlier. Then client app creates or updates the registration on the Notification Hub with the current handler. So in case of Notification Hub, after the client app has retrieved its current handle from the PNS, it updates the registration, or it does a registration on the Notification Hub, while in the push notification lifecycle, it updated the app's backend. So this is the difference. So again, when the send notification time comes, the app backend sends one message to the Notification Hub, and the Notification Hub pushes it to the PNS. So it becomes easier because Notification Hub has a couple of advantage over which is no platform specific protocols. So the first one, which is no platform specific protocols, is self-explanatory. Like, app backend has to communicate with the Notification Hub only. It doesn't have to communicate with anybody else. Avoid storing device information of the app backend. Because there's a Notification Hub and it maintains the registry of the devices and the interest groups, the backend is totally free. Third, broadcast, which is push notification to millions of devices across platform with single call from the app. All of this makes the notification hub as really advantageous to use. Let's see how sending notification to a specific device works. Well, again, it's very simple. You can use a concept called tagging, which means that you can tag a particular interest group, and then when you're sending the notification, you send the notification to a particular tag. Let's say all the phones in the diagram, let's say all the phones are the whalers and all the tablets are the beetles, and I want to send a particular notification, or I want to push a certain notification only to the beetle. I can do so by uh, by by saying the backend can target all the client with the tag beetles. These tags are nothing but simple strings. No pre-provisioning is required for them. You can also tag for the followers, that you can tag the users who follow bands as well as the users. Along with that, you can also tag devices with the user ID, which means that if a user has logged in to 2-3 devices with the same ID, same user ID, then notification to all of these devices will be pushed. So these are few ways you can send notification to specific devices if you have specific devices, and the concept used here is tag. This is the last slide of presentation, which says delivery guarantee and telemetry. Well, to be honest, Notification Hub does not provide a delivery guarantee. So if you have some important messages to be sent, or if you have important communication that needs to take place, make sure that that is delivered inside the application and not done through the push. So although the platform notification services try their best, but there can be scenarios in which the notification is not able to reach the devices. Hence, it is advisable that all the important communication should be delivered inside the app. Telemetry. Notification hubs provide powerful telemetry to track each and every outcome of the notification for each platform. So if you're sending if you're sending notification to different platforms and different devices, there can be scenarios where notification is successfully reaching, or notification is throttled, or the channel is expired, or there has to be someone who keeps a track of all this. So Notification Hub provides a very powerful telemetry. You can use it and access it through Windows Azure portal, and you can also access it programmatically. This is the end of our talk, ladies and gentlemen. Here is a slide which recaps whatever we have talked so far. We saw the background task architecture, how there are services, triggers, and background task infrastructure. We talked about the types of trigger and the new triggers in 8.1. We understood the concept of connected standby, which means that the hardware or the system is low on power and low on network. We understood about quiet hour, which is 12 a.m. to 6 a.m., which is in which background tasks are not allowed to run, and all of those are kept in a buffer or queued, and after the system comes out of the quiet hour, those are executed. After that, we saw what's new in 8.1. We saw what is hub notification hub. We saw push notifications lifecycle. We saw what are the challenges of push notification and the advantages of Notification Hub. With this, we conclude our webinar today. I want to remind you that if there are some developers who are going to begin Windows 8 app development, your help is provided to you in terms of design template. You can write down this alias aka.ms/winigtemplate.com. You can go to this website. There are 75 design reference template, high quality store compliant templates available. You can download these stored templates and then go ahead and jumpstart your app development. Along with that, if there are developers in the crowd right now who are in the middle of their application, or who are just beginning, or who are just finishing your application, if you need any kind of technical support, you can write to Windows Store App Lab on the email address w8pitcrew@microsoft.com, and they will get back to you. Along with that, appbuildersclub.com is the website which keeps on having a lot of amazing competitions. You can check it out. With this, there are a lot of resources. If you are developers who are just starting, you can take help from all of these resources. You can write to the App Labs, and all the best for your app development journey if you're just beginning, or congratulations if you're just ending. I hope this session was useful. Thank you so much for joining me. Thank you so much for spending your time here. And with this, we conclude our session.
Thank you,
We
Samiksha.
can
Thanks
take
for the
questions now.
insightful presentation. Let's quickly take up the questions now as we don't have much time with us. I request you to read out the questions and their answers so that all our
Okay.
users may listen to the
Right.
insights. So are you able to access the
Okay.
questions?
We have. Yes, I am. Thank you, Radna. Here's a question which says, what are toasts and badges? This question is from Naga Vamshidhar. Toasts and badges are nothing but the kind of notifications that your app can give. So if you use the previous Windows 7 apps, applications like Paint or anything else, if some communication needs to be done with you, there's a message pop-up box which comes, right? So in Windows 8, if there is some kind of notification or message that your application needs to give to you or to the user, they do so by using toast or badges. Toast is the rectangular notification that comes out from the top right corner of your screen, and badges are the small number or small pictures which are there on your tile on the bottom right or left corner. So this is toast and badge. If you want to know how to implement it, I suggest you go to msdn.com, and there are a lot of sample codes available, and that should help you. Uh, how much push set of? I'm not able to understand this question. Um, I think there's one question which says my Windows XP system goes to a white screen suddenly too frequently. What could be the issue? um, uh, your XP system goes to a white screen. Maybe you're overloading your system. Maybe you should check your RAM, or I don't know. I mean, white screen suddenly too frequently. Right now I can't answer this question because I need to understand what is the scenario when the white screen happens. Is it happening at the start? Is it happening at the end? Or is it happening when you're opening too many applications at the same time? By the way, you shouldn't use XP anymore. It's a time when Windows 8.1 has come. So I request you to go and update your PC, and probably you should use 8.1 because 8.1 are designed in such a way that your all the resources are given to the applications which are there on the foreground. Difference between Windows services and push services. What is the difference between Windows services and push services? See, push services are basically push notification service is the full name basically. Push notification service is used so that you can update your application or give notification to the user who's using your application in the real time through background task using the WNS, Windows Notification Service, which is a hosted service in the cloud. And that's the basic difference between Windows services and push service. Windows services, okay, do you mean Windows Notification Service and push service? Well, Windows Notification Service is used to to make push notification available in your application. I think that'll answer your question. Okay. Okay.
Samiksha, due to time constraint, can we end this session now? Do you want to sum up the session now? It's 6 o'clock already.
Yes, I think that'll be a good idea. It's almost 6. If you have more questions, you can put those questions in the TechGig forums. We can have discussions going on there, and we can have more insights in the TechGig forum. So I encourage you all to visit the techgig.com and write your questions in the forums, and you shall get your answers over there. Thank you so much, everyone. I hope background task and push notification makes sense now. Thank
Thank
you,
you,
Aradhna, for
Samiksha.
yeah.
Yes, due to time constraint, I would have to request you that you take the unanswered questions offline. I will share them with you through email. So I'm really thankful to our guest speaker today for conducting this wonderful webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Samiksha, for all your time. Have a great evening ahead. Okay, we are closing the session now. Thank you, Samiksha. Bye.